In this lesson, we're going to focus on the volume of prisms and cylinders. In the previous lessons, we basically talked about area and perimeter of basic shapes and composite shapes, but now we're ready to move on to 3D figures. And when we talk about 3D figures, we generally talk about volume and surface area. But in this course, we're specifically going to focus on volume of figures. So what is volume? Well, to simply put it, it is the amount of space something takes up. Volume is the amount of space that something takes up. And today we're going to learn how to calculate the volume of prisms and cylinders. So we also need to learn the definition of a prism and a cylinder. We're going to try to keep the definition simple. There are some more intense definitions, but we'll keep ours very simple. So what is a prism? Solid, or figure you can say, with bases that are parallel and congruent. And not only are they just congruent, they have the congruent polygons. So I'm not going to be testing you on the definition of what a prism is. Essentially, what we're going to do in this course is be given a figure and you have to establish that you have a prism. So for example, you have to establish that this is a prism, and not only is this a prism, you should know that this is a rectangular prism. Okay, and this is a triangular prism. And this over here is a pentagonal prism. So how do I know that this is a triangular prism and this is a pentagonal prism? So regardless of what kind of prism I show you, you need to be able to identify the base. Okay, that's going to be very important when we start doing the calculations of finding the volume. Because if you can't identify the base of the prism, then you cannot find the volume of the prism. So this is the face. This is the face that we're very interested in, because this is the base, or you can say this other face here is the base. So you have two faces here that are congruent and parallel. If they were not congruent or parallel, then you do not have a prism. So if you can imagine this triangle being much smaller than this triangle, then you will not have a prism. Okay, so for the pentagonal prism, you can go ahead and highlight the pentagon and show yourself the faces or the bases of the prism. For the rectangular prism, it's actually very interesting because you can highlight any pairs of faces that are facing each other, and they could be your bases, because you can actually imagine this rectangular prism. You can pick it up and turn it about, and you can have different pairs of faces which makes up your base. Okay, so the next shape we have to talk about are cylinders. So we're gonna go with a simple definition as well. So a solid with circular ends and one curved side. So solid with circular ends and one curved side. So you've seen cylinders in your life probably, soup cans, containers that fit tennis balls. But here, again, the base, you should really highlight the base because we're going to use that to perform our volume calculation. Now, one thing that is a big misconception is that students think cylinders are prisms. Now, when we do the math, you can say the cylinder behaves like the prism, but a cylinder is technically not a prism. Now, why is a cylinder technically not a prism? Because in order for you to be a prism, the bases have to be polygons, okay? And a circle is technically not a polygon. So I know when you think about it, or when you look at a cylinder, you just want to say it's a prism, but technically it's not. Okay, so we want to talk about the area of the base, and we want to talk about the height of a cylinder. So I've already mentioned this earlier. When you see a prism or see a cylinder, you need to establish two things. You need to establish what is the base of the cylinder or the prism, and what is the height of the prism or the cylinder. So the height, we have the definition here. It's the distance between the two end faces or the two bases. Okay, so what I've labeled here, this is the height. Okay, that's how far the two end faces are from each other. How about this cylinder here? That is the height of the cylinder. Once again, how far the two end faces are from each other. Now, the area of the base, that's just the area of the base. There's not much to say. So it's really important that you know how to calculate the area of the base, because that's referring back to what we did earlier when we talked about simple shapes or basic shapes. This is just a triangle, this is just a circle. So pi r squared here to find the area of the base, and this one is half times base times height. So why do we care about the height of the cylinder or prism and the base area of the prism and the cylinder? Because the volume of a prism or a cylinder can be found by simply taking the area of the base and multiplying by the height. The area of the base times the height. That's how you're going to find the volume of any prism or cylinder. Now, if you ever forget this, that's okay, because you have your formula sheet. Okay, the formula sheet will give you all the formulas, but that's how we derive all the volume formulas for prisms and cylinders. Okay, so on the back side, I showed you a diagram here. So we have a cylinder. Volume is equal to the area of the base times the height. So what's the base? It's a circle. It's a circle. So what's the area of the circle? Pi r squared. So that's why the volume of a cylinder is pi r squared times height, times h. Okay, what about rectangular prism? Well, what's the base? The base is a rectangle. So that's why it's length times width times height. Okay. Last one, you have a triangular prism. So we have B is the base of the base of the end face, and L is the height of the end face, because your end face is a triangle. So we can talk about the height of that triangle, which we've labeled L instead of H, because it's confusing. You can't put two H's, because you have to talk about the height of the triangle and height of the triangular prism. So we use L for the height of the triangle. Nonetheless, it's the same idea. Area of the base times the height. So this is area of the triangle times the height. Okay? Exact same idea. So let's practice. Let's do some questions here. So first one, we have rectangular prism. Beautiful. Length times width times height. Remember, you have your formula sheet if you forget. So 8 times 2 times 3. That's 16 times 3, which is 48 cubic centimeters. What about for the next one? The next one is a triangular prism. Okay, so let's write down the formula if you want. That's the formula, area of the base times the height. So that's 1.7 times 3.2 because the 2 and the half cancels each other out. So it's a 5.44 cubic meters. I forgot to mention, for volume, we'll work with cubic units because it's how much space you're taking up. So it's no longer square units, because square units was for area. All right. We have a cylinder here, so area of the circle times the height of the cylinder. So area of the circle is pi r squared times the height of the cylinder. We're going to approximate it to, let's say, 1 decimal place. All right, and last one here, we have a triangular prism here. A triangular prism. Now there's one number here that we're not going to use. I don't want you to be confused. And it's the 20 here, okay? Why are we not using the 20? Because if we are interested in finding the area of the base, which I'm going to highlight for you, this is the area of the base, which is a triangle. So how do I find the area of this triangle? Base times height divided by 2. So that 20 I do not need. And I know we are positioning this triangle prism in a different way than that we're used to, but this 10 centimeters, this is the height of the triangular prism, because you could, if you can imagine, you can stand this up and make this touch the ground. This triangle, you can make it touch the ground and stand it up, and this 10 centimeters will be, it'll be very apparent that it is indeed the height of your triangular prism. Anyways, I just don't want this 20 centimeter measurement here throwing you off. So let's go about and find the volume. When in doubt, if you're struggling with these calculations, what you should do is shade in the area of the base. So that way you won't make a mistake by finding the area of a face that is not your base. Like for example, if you found the area of this rectangle here, that would be a pretty bad idea. Okay, let's see what that's going to be. 960. All right. So you know what? I'm gonna go back to question B and C and just shade in the bases for you, or the end face, you can say as well. That's your end face or the base. All right, and then here. So establish what the end face is, and then find its area, and then multiply by the height, and there you go. That's going to give you the volume of your prism or cylinder. All right, let's see. Determine the volume of a cylindrical container that can just hold 6 stacked hockey pucks. Round your answer to the nearest cubic centimeter. So I know it's a little faint, but the radius of the puck is 7.6 centimeters, and the height of that puck is 2.5. So the volume of the container is equal to 6 times the volume of a puck. So the volume of a puck is going to be pi times 7.6 squared times 2.5. So it's pi r squared h. So the radius is 7.6 centimeters and the height is 2.5 centimeters. So just punch in your calculator. Let your calculator do all the work. So it said round to the nearest cubic centimeters. So this is approximately 2,722 cubic centimeters. Therefore, the container will have and will have a volume of approximately 2,722 cubic centimeters. Okay, next one. What is the volume of the container to the nearest cubic centimeter? I have a cylindrical container holding a stack of lip balms. So let's see. We have a height is 15 centimeters and 2.5 is the radius. All right, let's just, if you forgot, this is the formula for the volume of a cylinder, pi r squared h. So 2.5 centimeters is the radius, height is 15. So we're going to just nearest cubic centimeter. We're looking at approximately 295. Okay. How many lip balms with a volume of 59 cubic centimeters can this container hold? Assume the lip balm acts like water. So that's a big assumption. Okay. Because we're assuming that there's no empty space whatsoever, which is not realistic, but we're gonna make that assumption to make the math a little simpler. So if each of these tins, so the tins are right here, I suppose, if each of these tins of lip balm has a volume of 59 cubic centimeters, and the whole container is about 295 cubic centimeters, what I'm going to do is the number of tins is equal to your 295, the whole container, divided by 59, because that's the volume of each tin. So the whole container divided by the volume of one tin will give me the number of tins I can fit inside this container. And the answer is 5. We can, this container in real life, it's probably not going to hold 5 tins because, like I said, the lip balm can't act like water. There's going to be empty space. But for argument's sake, we're just going to divide 295 by 59. Okay, but the big idea, though, is your ability to find the volume of any prism and any cylinder. Now, although you will be getting the formula sheet, it should be it is a good idea to know how we came about the volume formulas for all the prisms and the cylinder. It's quite simply the area of the base times the height. Okay. Yes, we'll be giving you the formulas, but it's just a good idea to understand where we came about the ideas. So area of the base times height. If you have trouble identifying the area of the base, draw out the figure if it's not already given to you, and then shade in that that base. So you won't make a mistake by saying, like, for example, this side is the base. If you said this rectangle here is the base, that'd be really bad. But once you draw it out and look at the diagram, it's pretty obvious which face is the base. Okay, have fun.